Here's a basket full of capacitors and different power plugs. At first glance they just look like leftover old repair parts, but many of them still work perfectly well. Today I'm going to pick one capacitor and one male power plug from this pile to build a very simple homemade antenna. It sounds a little hard to believe, but sometimes these familiar old components can give surprisingly good results. And who knows, with just a few parts from this basket the signal might even turn out better than some store-bought antennas. Many people might be quite surprised by this. This small blue capacitor will be used as the main signal receiver for the homemade antenna I'm building today. Actually, capacitors don't just store and discharge electricity as commonly seen in electronic circuits. Inside there are two layers of conductive metal separated by a very thin insulating layer. When television signals are emitted into the air as high-frequency electromagnetic waves, these electromagnetic oscillations can induce these two metal layers and create very small voltage oscillations inside the capacitor. The important thing here is that television signals are essentially just high-frequency electromagnetic oscillations propagating through space. And any suitable conductor is capable of receiving some of those oscillations. Next, I have a piece of copper wire about 25 centimeters long, wrapped in a layer of shielding foam. This shielding helps reduce signal interference from the external environment and also makes the wire more rigid while securing the components. I'll use this wire to connect the capacitor to the positive power plug. Then I have a short piece of electrical wire. Both ends of this wire will be connected directly to the two terminals of the capacitor to create a more stable signal path between the connection points. These small details may seem simple, but loose connections or poor contact will noticeably weaken the signal. Continuing with the electrical connections, I'll apply hot glue to protect the contact points. This layer of glue helps to reduce vibration, prevent wire unraveling, and avoid oxidation after prolonged use. Jokingly, I'd say this tiny glue stick is more diligent in holding the wire together than a person keeping a promise. Next, since the signal receiver usually works in pairs to increase signal stability, I'll make another similar set, still using the capacitor, short piece of wire, and copper wire as before. And this next assembly step is also quite easy. Let's see how I do it. At the same time, to better dampen the vibrations of the copper wire supporting the capacitor, I'll bend it into a shock-absorbing spring shape. This structure helps the capacitor resist vibration during movement or minor impacts, thus making the connection much more durable. Now I'll move on to the base of the device. This is an old portable power outlet, and I'll repurpose it as the main body for the antenna. The great thing about this is that it can both connect to a positive power plug and provide space for a neatly connected coaxial cable. Next is a coaxial cable. This type of cable transmits the signal from the receiver to the TV with lower signal loss than regular electrical wire. First, I'll prepare one end of the cable for connection to a power outlet, and the other end will be processed later for direct connection to the TV. As mentioned earlier, I'll add a straight F connector and a 90-degree F connector to this end of the cable. Using the right angle connectors will make connecting to the TV much easier, especially for TVs placed close to the wall, avoiding the need to bend the cable. It's a real pain for the cable. And as you can see, the homemade antenna is now complete. I'll now test it to see how well it receives the signal. Before connecting the antenna to the TV, I'll check the TV's condition first so everyone can easily follow along. Currently, this TV has absolutely no signal, so the testing process will be more objective and avoid suspicion of pre-adjusted results. After connecting, the TV started displaying images. However, to ensure the signal is stable and not just a fleeting signal, we will continue monitoring for a while longer before drawing any final conclusions. So in the end, with just a few old electronic parts like capacitors, copper wire, and power plugs, I was able to complete a homemade antenna that can actually receive real TV signals. The interesting part of experiments like this isn't about expensive or modern components. It's about understanding how they work and finding completely different ways to reuse them. And honestly, every time I see a TV display a signal from something built by hand, it still feels surprisingly satisfying, almost like bringing old parts back to life again. If you have any other electronic components you'd like me to experiment with next, feel free to leave your ideas below.